And my first guest joins me in studio, Dr. Daniel Farkas. He is the chairman of Spectral Molecular Technology, stock symbol CSDT. Dr. Farkas, welcome to the program.
Thank you very much. It's very good to be here.
Now, I really was fascinating researching the company. You're described as a wholly owned subsidiary of Cascade Technologies. We'll talk more about that in just a moment. But you describe yourself as a company that has established a commercialized technology that can provide very early screening of cancer and other diseases. Please tell us more about that.
Yes, well, I very much welcome the opportunity to talk about things that we are trying to do, and also I think that my main goal is to do justice to the value of the concept which is behind what it is that we are doing. Everybody agrees that technology is and should be a powerful tool in alleviating human suffering and basically saving lives. And the question is, are we going about it the right way? And there's this very valuable concept that good things that were developed in the labs, in academic labs and also in commercial labs, should make their way all the way into the clinical realm. And it's not happening nearly with the speed and the efficiency with which it could and should. And one of the obstacles that we have identified is the fact that it may be that the technologies that we have in the clinic are not nearly as sophisticated as they are in the lab and as they should be. And so just to very quickly give you two examples, it seems to me that we have more advanced technology in our iPhone than we have in a typical operating room, where on a minute-by-minute basis lives are being saved and lost sometimes. The other one, which I always bring up, is that if you think about the Mars rover, we can today image dust on Mars better than we can image inside a human being in very serious trouble in our best hospital. And so that tells me that either the right people haven't been talking to the right people, or that we took a wrong turn somewhere, or that maybe there's a great opportunity out there. And so we would like to focus on what it would take to do things a little bit better. And that's...
Now, of course, spectral molecular imaging and the stock symbol CSDT, I understand that there's a stock symbol change, and that's going to be the actual name of the company, Spectral Molecular Imaging, right?
Spectral Molecular Imaging is a wholly owned subsidiary now of Cascade, but the company Cascade, we will have a name change that will better reflect what it is that we are doing, and it will be optical molecular imaging.
Okay, marvelous. Now, as I mentioned, I was very fascinated when researching the technology before this interview. You're based on imaging and analysis of human tissue using light to differentiate medically significant differences. I mean, I find that really fascinating. Tell us how that works.
Well, light is a very, very powerful investigational tool, and I think it's much richer as a tool than some of the currently very accepted and successful methods of biomedical imaging, which include X-rays and spin in magnetic resonance imaging and ultrasound and so forth. And to some extent it's already used in the clinic. In particular, endoscopy has been very successful, and I think if you add up the top 5 companies in endoscopy, they made something like $16–17 billion last year. But it's still not a guarantee that everything that we would like the imaging to give us is available even via endoscopy, which is a magical concept, by the way. We put the surgeon basically at the location where the trouble might be and then try to do something about it. And so our concept is that Francis Bacon, who was hundreds of years ahead of his time, said that it would be madness and inconsistency to presume that things not yet done can be done except by means not yet tried. So it's kind of a call to arms for developing new technologies that may be better than the old technologies, and the low-hanging fruit has pretty much been collected. So if we want to really determine whether something has a particular signature that should tell us that it's cancer, why not try to do it really early? There was a very well-received paper about 5 years ago in Fortune magazine. I think it's still the most downloaded article ever on Fortune magazine, which was entitled very interestingly, Why Are We Losing the War on Cancer? And amongst other very good points, one of the points made was that the only thing that currently works is early detection. And so we really would like to focus in on early detection, and then by very definition, the early detection means that you're trying to find something which is barely different from normal. But if that barely different issue can be quantitated and in a reproducible way found, and obviously you need some technology to do that, that would be the cornerstone of you being able to detect disease early enough that the outcome is massively different from late detection.
You know, now we see something in the neighborhood of like 50,000 cases per year in the U.S. of melanoma.
Yes.
And exceeding 15% of those cases wind up being fatal. You have a technology called Skinspect. Tell us how Skinspect works to help detect melanoma earlier.
Yes, melanoma is a major problem. It's really the cancer that has been growing the fastest of all cancers, and I don't know whether it's the sun worshipping of the 60s and the 70s, or the hole in the ozone layer, or probably the tanning beds, or maybe a combination of those. But it's really, for young women, for instance, between the ages of 25 and 35, it's the biggest killer.
Wow.
And it's the #1 cancer also in terms of incidence.
Wow.
So the incidence has been going up in a precipitous way. And I don't know of any other disease where early detection can make such a huge difference as in melanoma. If you find it early, it's practically 100% cure.
Wow.
And if you find it late, it's almost 100% death.
Hmm.
So clearly we are incentivized to look for it very early. And so the technology that we have decided to use, and this is the enabling technology which stands behind our company, is called hyperspectral imaging. This is a technology that we are using on satellite reconnaissance missions. And those things are designed to find things which are tough to find. So when you basically use a spy satellite, you're not trying to find a black tank in a white desert. You're trying to find a green tank on the green camouflage canopy in a green forest, and that therefore barely different from its surroundings.
Sure.
Nevertheless, if you have a high enough technology, you can find it. And so we have taken what has been developed for these kinds of applications for the last 40 plus years, and we adapted it and adopted it for the biomedical field, starting with easy applications like cytopathology and histopathology, but eventually moving into the live diagnosis of disease, and this is really our focus now.
Well, Daniel, what do doctors do now to detect melanoma previous to your technology?
Well, they try to do the best they can with technologies that we do have, and in fact the eye and the brain are a terrific detection tool, and so basically the bulk of what is being done is very highly trained professionals looking with all the experience accumulated at the lesion with their own eyes, and then when they see something suspicious, it's being taken off. Unfortunately, you could have done this in the days of the Roman Empire, so I think in the 21st century you have to do better than that.
So, you know, it's simple visual inspection
Yes.
versus your technology, which can detect it much earlier.
Well, there's also a newer method which is called dermoscopy, but basically what it is, it's a little piece of optics and then a color camera. So if color camera was the way to detect the difficult to detect things, that's what would be flying on the satellites, what is not the case.
Now, will your technologies require FDA approval before you can bring them to market?
Yes, most technologies that are going into the clinic do require FDA approval. We have a couple of things that we are doing that are not FDA regulated, but most of what we do is FDA regulated, although I don't think that people should be that worried about the FDA. The FDA has been getting faster. They really would like to get devices through. I have studied the matter a little bit, and I have seen that when somebody brings something totally original or something that cannot be done in other ways, the approval has been as fast as 24 days.
Wow.
Typically for devices like 90 days before they look at you. And if you are convincing, you can get through in a couple of months.
Interesting. Why is this a good time right now, Daniel, for folks to take a closer look at your company?
Well, I think that what would be really exciting is not only to bring new technologies which are clearly possibly better than what is done today, but also in the process maybe save the system money. Everybody assumes that new technologies are going to be more expensive than current standard. It's not the case. If you do it right, I think you could save money, and in fact optical imaging has such a potential versus other types of imaging that I think that it's an industry which is going to be rising very quickly.
So much information. I wish this was a half-an-hour interview, but I know that we need to move on. We're going to be watching your company very closely over the next 3 months, initiating coverage this week. I'd like to invite you back on for updates and get more into this story. Fascinating technology. Thanks for joining us.
Thank you so much for the opportunity.
Take care.
Thank you.